Just as the man gets to the top of the building, he realizes that he left some really important documents in his car, in the car park below the building. So he gets back on the lift and uses it to descend down to the car park. So if the lift accelerates downwards with an acceleration of 1.5 meters per second, what would the scales read?
Okay, so here's the man in the lift. It's accelerating downwards at 1.5 meters per second. And the force is acting on the man. He's still got his weight force acting downwards, and in this case he's got this normal reaction force from the scales acting upwards. So we know that the acceleration is equal to the net force on the man over the mass of the man from Newton's second law. And so we've got the weight force of the man acting downwards plus the normal force acting upwards is equal to the acceleration, which in this case is going downwards, and this is divided by the mass of the man. So once again, we've got downwards ma is equal to mg downwards plus the normal force upwards, and we're trying to find this normal force, which is equal to ma downwards minus mg downwards. So that is equal to ma downwards plus mg upwards. And so we've got 80 for the mass. You can take the 80 kilograms out as a common factor, and we've got 1.5 downwards plus 9.8 upwards. So this is 9.8 minus 1.5 upwards, and so this gives us 80 times 8.3, which is equal to 664 newtons upwards. So to get a reading on the scales, we just divide by 9.8. So reading on scales is 664 over 9.8, which is 67.8 kilograms. So this is aligned with what you feel on the lift. When you get into a lift and it starts to descend, you can feel the floor moving away from you. So you actually feel less force from the floor on your feet, which is why this mass is less than the 80 kilograms which the man actually weighs.